Is it too late? Tell me. Is it too late? The original title for this video was How to Avoid the Terralith, but obviously not many people know what the Terralith is, so today we're gonna see what is a Terralith and why we should avoid it. If you're new, hi, this is Out of DevOps, my name is Anto and I talk about software engineering and software engineers. See you after the intro. What is a Terralith? Let's say you are just starting creating your infrastructure. So you learn about something called Terraform. The first thing you do, you go on this website and you start looking around for code to copy and paste. So the first thing you do, you copy and paste few definitions here and there, and in a few hours you get something that kind of works, and you are eager to demo this to everyone in your company. So what you do in a couple of days, you do a nice presentation and then you say, ta-da! Here we go, this is our dev environment. And I'm pretty sure someone in the audience, probably someone important, will ask you the following question. How long does it take to create more environments? And can we push this to prod? So your answer would be, give me a couple of hours and I just rename a few variables and you can have as many environments as you want. Congratulations, you just created your first Terralith. So a Terralith is when you have in a single Terraform definition all your resources for every single environment. So your entire infrastructure is created using one single plan, one single apply command. So this is tempting, right? So having the power to create absolutely everything with a single command is very appealing, but there are a number of downsides to this. So I identified 7 downsides of the Terralith, so we're gonna see one by one, and we are also gonna mention what are the complexity when we try to manage a Terralith. So let's start. So these are the 7 downsides of using a Terralith. So the first one is environment isolation. The second one is speed. Third one, readability. Fourth one is collaboration. Obviously I'm reading. Fifth is security. Sixth, testing. And seventh is code reusability or reuse of code. So let's start with the environment isolation. So environment isolation is very important because in many industries you need to have, as a requirement for from regulators, you need to have environment isolation and different level of access per environment. So in a Terralith you have every single environment coming from a single piece of Terraform. So that means every single time you are modifying something in a dev environment, you have the potential to affect the production environment. This means every single time you are doing any type of change, a silly mistake like renaming a variable or renaming a Terraform definition can absolutely destroy your entire infrastructure. So for example, you rename a single Terraform definition or the name of the module, and then you end up recreating your infrastructure not just in a single environment but everywhere. So you lose the ability to test your changes in a lower environment because everything will be affected. So hope this is clear. This is quite easy to avoid, so make sure you isolate the definition of your environments into independent Terraform plan and apply. So the second thing is speed. So when you have a huge list of resources in a single Terraform plan, the plan may take several minutes, but that's not just the time, it's also you may end up hitting rate limits on the cloud API, because every single time you plan, you are doing a huge number of requests against the cloud APIs and you may hit the quota. So that's another thing. So speed will be affected. So consider that if your plan takes something like 30 minutes, you can only plan 16 times in a 8-hour workday, right? So it's very, very limiting. So now, third one, readability. Readability, so imagine you have everything in a single file or everything in a single repo, multiple files. You have to navigate a huge number of resources trying to figure out where things are. So instead you can organize individual repos or individual folders with specific components inside, and it's going to be much easier to navigate those resources, because most of the time lots of people with different background will interact with the infrastructure repository, and this will lead to inconsistencies, especially with naming convention and other things. So it's really going to be problematic to read the code and understand your Terraform code. So most of the time you just hit plan, apply, and hope for the best. So the other thing is collaboration. So when you have a single Terraform plan and apply, collaboration is extremely difficult because every single change cannot be run in parallel. So you cannot, even if you have multiple branches, you're gonna plan against a different result because it depends on the sequence of merges that you're gonna do next. So most of the time can be pointless to do a plan if there is something else to merge, because you have to do plan again. There is also another thing, the collaboration is limited, so the parallelism is limited because every single time you plan, you lock the state, so no one else can plan at the same time. So you are still planning sequentially, but in addition, the result will not be reliable because it may change since other people are changing the repo. So fifth thing is security. So now if you have a single Terraform definition where you put your VPC configuration, your firewall rules, your load balancers, every single VM, your Kubernetes cluster, and your databases, you need to have a service account that operates on all these resources. So you will end up on having a service account that is super admin, not only for these resources in a specific environment, but for these resources in every single environment. So now you have a service account that has the potential to affect every single resource in every single environment. So now you have two risks. One is the blast radius. So if you make a mistake, you can literally destroy everything with this level of permissions. Two is security risk from attacker point of view, because if these service account credentials get compromised, whoever has access to them can literally create and destroy everything in your organization. So that's a really crucial point. That's where many people get burned by creating the Terralith and then having to fix it later. So now testability is another one, right? So to test infrastructure as code, there is one thing to do. So you cannot do any test without the cloud provider. So you need to test against the cloud provider, which means you need to provision the resources. So if you want to test your Terraform code into another project or into another organization, you still have the problem of creating absolutely everything every single time. So you cannot test single components in isolation because everything is one huge Terraform plan and apply. Hopefully this is clear and doesn't need more explanation. And finally, the last thing is reuse of code. So in a Terralith, it's very hard to reuse the code. Even if you use modules in the same repo, you may want to have different versions. Let's assume we create a module for a VM. We want to be able to version and upgrade VMs individually, not all at the same time. So it's going to be hard to maintain different versions of the module in the same repo. So now we saw all the 7 downsides of using a Terralith, but is it just downsides or there is any benefit in using a Terralith? So I wouldn't say these are benefits. I would probably say there are things to consider, right? So this is very similar to the approach we had a while ago when we started moving our architecture from a layered architecture to a microservices architecture. And what happened there was that we ended up decomposing our monolithic application from a single Java program to many different microservices. Soon we realized that managing multiple services is not a trivial task. So it's easy to create a microservice, it's hard to manage and orchestrate many microservices. So with infrastructure as code, the problem is very similar, because when you have a single Terraform code base, Terraform takes care automatically of the dependencies, because all the resources live under the same execution. Terraform can identify the dependency graph and then execute the resources one by one following the graph. When we split the Terralith, we need to make sure all these dependencies are still considered as part of the plan and apply. So because now we have multiple plans and apply, those needs to be executed in a specific order. Keeping track of the order needs additional components, like, I don't know, some sort of CI/CD pipeline for infrastructure. And dependency management is not the only thing to do. So before we mention the creation of modules, we need to have a continuous testing system because with the time the cloud APIs will evolve and there may be incompatibilities. It's not just the cloud API that evolves, it's also the Terraform code base that may become obsolete because new resources are created or new definition for each resource are created, but also new version of Terraform may be incompatible with the previous definition. So we need to have some sort of automated testing framework where our modules are constantly tested and validated. And we may want also to introduce new things like blue-green provisioning for infrastructure. So instead of destroying and recreating the infrastructure, we're going to have an approach that is more conservative, where we don't touch the old infrastructure, we create the new one and we migrate. So this is to say that infrastructure as code is very easy in the beginning, but it can become very quickly extremely difficult to manage, especially because once you have it and the application is running on your infrastructure, you will end up having to coordinate with so many teams for every single infrastructure change that will be almost impossible, and even a single change may take months because you are serving customers and you cannot stop the infrastructure because now you want to refactor your Terralith or because you want to fix some design problems in your infrastructure as code. So now I hope Terralith is a new word in your vocabulary and you know how to avoid it. Let me know if you already had experience with managing a Terralith, decomposing a Terralith, what was the technique that you used down in the comments. And as usual, don't forget to comment, like and subscribe, and see you in the next video. Bye!